So why are extraneous roots sometimes produced when solving radical equations? So a good example would be to just think of it visually. And if I have a square root equaling a negative number, that's where my extraneous roots can show up. So for example, if square root x equals negative 4, then the left side of my equation I've graphed as a square root function. The right side I can graph as a straight line, y equals negative 4. And we can see that they do not intersect, so they have no solution. Now, where the extraneous solution comes in is when we square this expression. When we square both sides of this, I'm introducing the other half of the parabola. So the negative half of that parabola then actually shows up, because when we square it, we don't know if it was plus or minus inside the square here. So it accounts for that negative square root as well, and it gives us this graph, the bottom half of that parabola. And it then gives us this extraneous solution, which really doesn't exist, because the original equation is square root equals negative 4. So when I solve this algebraically, I get x, because I don't know if it was negative on the outside or not. And I square this, I end up with x equals 16, and there's my solution. I end up with x equals 16 as a solution, which is extraneous. Okay, so this is an example how we can generate extraneous roots. We can also show some examples here where we have, I think we did this in a previous question, where we can generate solutions that have extraneous and non-extraneous roots. So for example, if I draw a linear equation through here, so for example, maybe that's x minus 5. Okay, I have a solution here. Okay, that's a valid solution. But when I square both sides of this, so again, when I square both sides, what happens then is this inside function could have been negative or positive and gives us the same solution. So we're generating the negative side of this parabola, okay, and which then allows us to find, when we solve this algebraically, we have an extraneous solution that will show up. So I end up with x squared minus, what would this be? So this is just going to be x squared minus 10x plus 25. Okay, and then I solve this, I end up with this quadratic equation. I'm going to end up with two solutions here. Okay, this is not factorable, so I'm going to end up with a solution that looks like this. X equals plus minus 11 plus minus 121 minus 4 times a times c. And so I end up with two solutions here. This is going to be square root of 21. So one of these solutions is extraneous, and the other one is the valid solution that I see where the red and the green intersect.